for the very end of the review that you guys got at the beginning of this week. So I'm going to go through 5, 6, 7, and 8. And you can just find them on your packet. I understand it might be hard to read this, but you have your packet. So number 5, use the table of bond enthalpies below to calculate that D is like a delta. And actually in your paper it's a delta. It copied as a D when I copied and pasted. The delta H for the following reactions. So the first reaction we have hydrogen gas and chlorine gas reacting to form HCl. And then I have this guy. So what you guys can do is you can use how we've looked at HONC, 1, 2, 3, 4, hydrogen forming 1 bond, oxygen 2, carbon, or nitrogen 3, carbon 4, and also we saw the pattern as you go across the periodic table. When we do that C, N, and O, we're saying on the periodic table it goes carbon, and then nitrogen, and then oxygen, and then fluorine, and then neon. And what you guys can do is you can see a pattern. We know that this forms 4 bonds, this forms 3, this forms 2, this forms 1, this forms 0, and the things below it tend to form those bonds as well. This only works for the easy Lewis dot structures, for the simple ones, but that's what we're focusing on. You're also allowed to add up valence electrons and move them around so that everything is surrounded by 8 valence electrons, except for hydrogen will be by 2 to be satisfied. So I'll do this one. I want to know how much energy I'm putting in, because I put in energy to separate things that are attracted. That's endothermic. It's hard to separate things that are stable together. I'm making them less stable, just like a ball is less stable at the top of a hill. So I'm going to separate an H, and it's H2. They each have 1 valence electron, so 2 electrons bonding those. And then I've got Cl2. So chlorine, chlorine. Each one has 7 valence electrons, so I've got 1, 2, 3, 4, 5, 6, 7, and different color. 1, 2, 3, 4, 5, 6, 7. Okay, so they're sharing 1 pair, so that's just 1 bond. All right, and I'm going to make from that 2 HCl's. So that means energy is going to be formed and given off from these guys. I've got 1, 2, 3, 4, 5, 6, 7 electrons from the chlorine. Ooh, I'll make my hydrogens blue. And 1 electron from the hydrogen. So you can see there's a single bond there. I just have HCl. Okay, so this is the same as that. So what I'll do is I'll add up how much energy did I put in to break that. Well, I put in this much. Plus how much energy did I put in to break that bond. It's going to be right below it. And then I'm releasing, so that's a negative change, energy for 2 of these bonds. So that's 2 times the HCl bond. So positive, negative, and you'll get your overall. Do the same for here. Just draw out your Lewis dot structures first and see how many bonds you're breaking. For number 6, it says, this question concerns the alcohol propan-1-ol. Define standard enthalpy of formation. This is when I say to you guys, I usually just say enthalpy of formation is when you form and you say 1 mole of something from, and you'll say elements, and I'll say in there, and that's when you say standard state under standard condition, and we smile. That's the definition. So you're going to write the equation showing that. So just make sure you form 1 mole from its elements, and you can see what elements make it up, put them in their standard state. You have that one. Then the next one, define standard enthalpy of combustion. From all those steps you wrote on that first page, I bet you have this one now. So combustion is when you react with, you just said oxygen, I'm sure of it. Okay, so make sure, one tricky thing, you balance this so you're only reacting 1 mole of a substance. When it says write an equation representing the standard enthalpy of combustion of propan-1-ol, make sure you only combust 1 mole of propan-1-ol. That might mean you need to use fractions of oxygen. Maybe, maybe not. Hess's law, that's what we've been doing. So put it in your own words. What is it that we've been doing to relate the steps to the overall reaction? This is saying Hess's law tells us how the steps are related to the overall reaction. So you tell me how the enthalpy of the steps is related to the enthalpy of the overall reaction. And number 8, this question concerns the organic compound propane. The standard enthalpy of formation of propane is given at negative 103.9 kilojoules per mole. Write the chemical equation that would represent an enthalpy change of negative 207.8. Well, you can go straight to it, or if you're stuck on this one, which if you're watching the pointers, maybe you're stuck. Well, I know that I have an enthalpy of formation equation that's probably going to be useful. So I'll go ahead and form 1 mole of this from its elements in standard state. All right, I've got that equation. I'll know that equation's worth this. And you can see what you need to do to that equation to make it worth that. And then you should probably do a victory dance because you're done.